Hi, my name is Katharine Hayhoe. I'm a climate scientist. I am also the chief scientist for the Nature Conservancy, and I'm a professor at Texas Tech University. Geoscience education is very near and dear to my own heart, not only because that's what I do too. I teach graduate and undergraduate students at the university. I often guest teach classes to high school, middle school, or even elementary school kids, which I absolutely love. But geoscience is not only what I do, it's actually why I'm a scientist. Yes, the reason I'm a scientist is because my dad was a science teacher. And so he taught us from an early age that science is the coolest, most interesting, most fascinating thing that anyone could possibly study. Doesn't everybody want to understand the way the universe works? And so, of course, being indoctrinated with science from an early age, I agreed. And it's not only that. Why is my dad a science teacher? Well, my grandmother, although she never worked outside the home, she had 8 children and she had a degree in science education. In fact, she named my father after Dr. Vibert Douglas, who's the first woman in Canada to become an astrophysicist. And my dad loves astronomy. In fact, one of my earliest memories is going to the park when I was 3 or 4 years old and him teaching me how to find the Andromeda Galaxy through binoculars. And so it's no surprise that I was well on my way to becoming an astrophysicist myself. That is actually what my undergraduate degree is in, when I serendipitously took a class on climate science. And that was what changed my life. Now I study this incredible planet that we live on. And when we study this planet, the more we study it, the more we understand about what's happening to it today and why climate change is so urgent. Let's start way back in the past. As far back as we can look in the history of this planet, we know that climate has changed. Why? Due to natural factors. Over long time scales, the rearrangement of the continents, weathering and erosion changes the balance of carbon in the atmosphere. Over shorter time scales, variations in energy from the sun, natural cycles that exchange heat between the ocean and the atmosphere, and even large-scale volcanic eruptions can all, and have in the past, affected climate. So if these changes have happened naturally before, what's the problem? The problem is that we humans are interfering with these natural processes. How? Well, when we figured out how to dig massive amounts of coal out of the ground back at the beginning of the Industrial Revolution and burn it, that began the precipitous increase in heat-trapping gases that we have seen since then. Heat-trapping gases, of course, also occur naturally. So again, what's the problem? This short video explains. Our planet has this amazing natural blanket. It's made up of carbon dioxide, methane, and water vapor. The sun's energy shines down and goes right through that blanket as if it were a window. It hits the Earth and the Earth warms up. The Earth gives off heat energy. But just like a blanket traps our body heat on a cold night, in the same way this amazing natural blanket traps the Earth's heat, keeping our planet almost 60 degrees Fahrenheit, about 30 degrees Celsius, warmer than it would be otherwise. The problem is we're adding more of these heat-trapping gases to the atmosphere, and we are in essence wrapping an extra blanket around our planet. What would happen if you were sleeping at night and somebody snuck in, like my grandma used to do, and put an extra blanket over you? You'd start to sweat because you didn't need that blanket. That's what's happening to our planet. Our planet is running a fever. A fever is a direct result of this extra blanket that we are wrapping around our planet. Where do these gases come from? They come from our transportation, cars, trucks, shipping, trains, airplanes. They come from industry and manufacturing. They come from the electricity that powers our refrigerators and our lights. And they also come from land use change, deforestation, and large-scale industrial agriculture. Now, don't get me wrong, the Industrial Revolution has brought us tremendous benefits. Imagine what your life would be like without refrigeration or electricity or transportation or all the medical advances that the Industrial Revolution brought us. But at the same time, we know that there is no free lunch. And that is exactly what we are experiencing today. Today, we know that thanks to all those heat-trapping gases building up in the atmosphere, we humans are now the dominant influence on climate. The way I think about it is this. For many thousands of years, humans were skitching on the back of the bus, so to speak. I bet you never thought you'd hear a talk on climate change that used this metaphor. We were sort of on the skateboard, hanging on precariously in a very dangerous and unsafe position at the back of the bus, while the bus did whatever it wanted. Well, what's happened? Over time, we have opened the back door of the bus, we have crawled into the bus, we have walked all the way to the front, and we have elbowed the driver out of the driver's seat, and we humans are now sitting on the driver's seat of that bus with our foot on the gas pedal, accelerating faster and faster into a very dangerous curve. And so today, the situation looks like this. This is a real video, but I made sure that there was no one seriously injured in this accident. You have the bus driving down the road, not looking carefully at where it's going. It hits the curb, and this is exactly where we are today. We see the danger. We're starting to experience some of the danger today, and the time to prevent even more serious consequences is now. As I wrote with one of my colleagues, Bob Kopp, a number of years ago, we said, Aristotle might argue that humans were not responsible for the choices made at the beginning of the industrial era, when collective scientific and societal knowledge limited our capacity to choose wisely and well. Regardless of our original ignorance, however, over the last few centuries, we have been conducting an unprecedented experiment with Earth's climate system, which is the only home that we have. That is how serious this problem is. So what can we as educators do? These thoughts are only intended to begin the discussion, certainly not to provide the final word or even end it. In fact, after this talk, you're going to go into discussion groups to talk about it even more. So what I want to do is I sort of want to introduce this by sharing 3 thoughts that I have found helpful to focus on when we're talking to kids and students about this issue. What are these 3 thoughts? Well, the first one relates to information and facts, which of course, when we teach science, we've got a lot of. It is very important to understand and to clearly communicate the facts, because whether we like them or not, they're true. When it comes to climate change, what are the facts? Climate is changing. Humans are responsible today. In fact, according to those natural factors, our planet should be getting very slowly, gradually cooler, not warmer. Scientists agree that yes, it is us. The impacts are serious, and there are solutions now. But here's the thing. Facts alone are not enough. Are they important? Of course they're important because they explain the way the world works. But why are they not enough? Because how our human brain interacts with information, interacts with the facts, is just as important, if not perhaps even more important. Because you could have the best facts in the world, the most accurate facts. You could have all the information that you needed to make the right decision. And if you did not use that information, the facts have availed you nothing. So when it comes to communicating facts, there's 3 key things to keep an eye out for. At least 3, probably more, and you can come up with those in your discussion groups. Number 1, though, is the fact that often we were taught ourselves, and we in turn teach others this way, we teach according to the knowledge deficit model. The idea that students and people in general are willing and able to process information correctly if we just give it to them. But that is not necessarily or always the case. Not with science in general and not with climate change specifically. Why not? Well, first of all, we have the mental models issue. A mental model is a model that we have in our heads, hence the mental, that explains something about the way the world works. And research has showed that even very young children can have quite sophisticated mental models explaining the way the world works. They're little scientists, aren't they? One classic example was when they found that a lot of students thought at a very young age, well, it's summer because we're closer to the sun, and it's winter because we're further away from the sun. So even though they were taught the correct reason for summer and winter, which relates to the tilt of the Earth's axis of rotation relative to the plane of the orbit, they reverted to their original mental model afterwards because it hadn't been debunked. And it sort of made more intuitive sense. But what research has found is that when we walk students through why that model doesn't work, okay, well, what about Australia? Why is it summer in Australia when it's winter in the Northern Hemisphere? That just really doesn't make sense. If we understand what people are thinking ahead of time and we walk them through it, then the information we provide, the correct explanation, is stickier afterwards. So we actually tested this out with climate change. We looked at a lot of common misconceptions that people have when it comes to global warming, like what? Like, it's just the ozone hole letting in more of the sun's energy is one of them. And so we created 2 sets of reading materials, not very long, about 1,500 words each, and this was for university students. We created 2 sets of reading materials, one that explained the greenhouse effect and humans and how they were affecting it and global warming. And then one that did the same thing, but it added information on the misconceptions or the incorrect mental models that students might have had and why those weren't right. Immediately afterwards, we found that the 2 groups improved in their understanding of global warming and the enhanced greenhouse effect pretty much equally. But then, when we did a delayed post-test, guess what? The students who had the information on misconceptions retained the information better and for longer than the students who didn't. So understanding what ideas people have in their head ahead of time and specifically addressing those ideas is a really important way to make sure that the information, the facts that we impart, have longevity. When it comes to climate change, though, we have some extra issues to cope with. Like what? Like the fact that the United States is more politically polarized than ever today. And of all the many issues that are politically polarized because of that, guess what? Climate change is number 1. Yes, you heard that right. This survey done back in February 2020, just before COVID hit, ranks all of the different political issues, so to speak, and of course, whether climate is changing is not political at all, but it ranked all the issues that are being talked about or debated in political circles, and the gray bar, the width of the gray bar, shows how far apart the average Republican and Democrat are, and as you can see, climate change and environmental protection were at the very top of the most politically polarized topics in the whole U.S., immediately preceding COVID. Then COVID came along, and what do you think happened? They redid this survey in August, and these results are not ranked by the width of the gray bar, so I'm going to point out number 3, 2, and 1 for you. Number 3 most politically polarized issue became the COVID outbreak. Number 2 became race and ethnic inequality with the Black Lives Matter movement, but climate change was still firmly lodged at number 1. And so because of this, the number 1 predictor about what adults think about climate change is not how educated they are, how much science they know, or how smart they are. It is simply where they fall on the political spectrum. That is the number 1 predictor of whether we agree with the facts I showed before, that climate is changing, humans are responsible, scientists agree, the impacts are serious, and there are solutions now. In fact, I found this out myself the hard way, the very first class I ever taught at Texas Tech. If you've seen my TED Talk, you'll know that I start off with a story about how a colleague asked me to guest teach his geology undergraduate class while he was away one day. I said I was happy to do so, so I carefully prepared a long talk on the whole history of the carbon cycle over the geologic history of the Earth. And at the very end, I mentioned very briefly how humans are disrupting the global carbon cycle by digging up and burning fossil fuels, accelerating the movement of carbon from the lithosphere into the atmosphere by orders of magnitude compared to what would happen naturally. And if you watch the TED Talk, you'll know this. After my talk, I asked for questions, and it wasn't like it was a grade 3 class. This was an undergraduate class, so there were no questions. Except finally, one guy sort of halfway up the kind of tiered seating, raised his hand, and I was like, yes, question. And he stood up and he said, "Are you a Democrat?" I was absolutely floored because I did not know that climate change was the most politically polarized issue in the country back then. And I didn't know what to say other than, no, I'm Canadian. So how does this political polarization affect our ability to process information and facts? Well, to understand this, we actually can go to neuroscience of all things. Tali Sherrod is a neuroscientist. She wrote a fascinating book called The Influential Mind that I highly recommend. And in it, she says a number of very pertinent things, including this. She says, our brains are programmed to get a kick out of information, but when we give people new info, they typically only accept it if they already believe it. If it contradicts what they believe, then their brain shuts off. Oh my goodness. And then Dan Kahan is a social scientist from Yale University, and he specifically studies science literacy, science knowledge, and climate change, as well as other contentious issues. And what he found is that members of the public with the highest amount of science literacy, they're not most concerned about climate change. They are the ones who are what? Most polarized about climate change. And in fact, he went on to study this, and he found that being smarter does not make you more accepting of science. It just makes you better able to cherry pick the information you need to prove that you're right. Now, all of this research specifically relates to adults. And kids' brains are often much more open and eager and curious than adults are. They haven't formed such a defined political identity that's tied to things like rejecting the science of climate change. But it's important to understand this because as a result, all of us, children, teens, young adults, teachers, parents, all of us, we are subjected to misinformation all the time, and some of it can come from people we trust. Like who? Well, like our own relatives, or celebrities, or politicians, or things that we read online. We're constantly being bombarded with information that says it isn't real, it isn't us, it isn't serious. So that's why I have global weirding episodes on these topics. I have a global weirding episode on how do we know it isn't just a natural cycle. Another global weirding episode on if it's just a few degrees, who cares? And isn't warmer better? Because a lot of this is things that we hear all the time. And so remember, think back to the first part I was talking about, we need to know where people are coming from. We need to know what sort of mental models or misconceptions they already have, because if we don't address those directly, often the correct information that we provide will not be sticky. And it will disappear even if they initially accept it, and they'll go back to what they originally thought. There's also a third issue, which I'm sure you're very familiar with, and that is the fact that sometimes science can be a bit boring. Could science really be boring? Well, no, of course not. Science can never actually be boring, but sometimes it can come across like that. And we want to avoid that at all costs because we know that curiosity fosters learning. In fact, for example, one of my colleagues right here at Texas Tech University, Ashley Landrum, she studies scientific curiosity. And in one study, for example, she looked at how interested people were in watching a video about a science topic. Ordinary science intelligence, that's the OSI that you see here on the figure. That's their ability to engage in quantitative reasoning and understand statistics and data and things like that. And there was a very weak positive correlation between OSI and how engaged people were in the video. But then Ashley also has something she calls a scientific curiosity scale. That's the SCS. And what she found is that people's curiosity was what kept them engaged. The more curious they were, the more they wanted to know. So what are my tips for this first section? First of all, be conscious of, and even I would say, take the time to draw out and elucidate and find out what are the misconceptions, what are the mental models that students might have. Engage their curiosity in discovering information, not just presenting it to them. There's also resources where you can bring people into the classroom. There's a fantastic program called Skype a Scientist. I don't know if you've heard of it, but you can actually Skype a scientist from your classroom who will talk to your kids about what they do, which is amazing. I just finished writing a book called Saving Us, A Climate Scientist's Case for Hope and Healing in a Divided World. It's coming out in September, but you can already pre-order it now. And in it, I talk about some experiments, for example, that Kirsten Milks, who's a teacher herself, does in her classroom. What she does at the beginning of the year is she gets students to write all their questions and she puts them up. And then she says, okay, today we're going to answer this question. And today we're going to answer that question. And that way you're honoring and respecting the students' questions, you're feeding their curiosity, you're answering the questions they want answered, and you can do some really fun experiments like creating your own ice cores, for example, in Pringles cans, or looking at data for your local area. There's all kinds of things that you can do to engage that amazing curiosity that students have. But that's not all, not nearly all. This is only the first thought I had to share with you. Let's go on to number 2. The second issue is this. When it comes to climate change, as humans, we all share a disadvantage, and that is our tendency to psychologically distance ourselves from things that we don't think are immediately relevant to us or that we don't think we can do anything about. It's a defense mechanism that can prevent us from becoming overwhelmed, but sometimes, like now with climate change, it can lead us astray. What does psychological distance look like? I'm going to illustrate it using these maps from the Yale Program on Climate Communication. These are amazing maps that you can look at with your students. You can go to each county and each congressional district, and they also have these results by riding for Canada, and you can dig into what people in your county think about 30 different questions. I'm going to highlight a few of them to illustrate how these maps, how this public opinion data shows psychological distance. So anything that is yellow or orange is more than 50% of people say yes, and the darker red it is, the more people say yes. And then anything that's blue is less than 50%, and of course the darker it is, the more people say no. So they say, do you think global warming is happening? And as of last year, 72% of people said yes. So it's happening, and then they said, do you think it will harm plants and animals? Same numbers, yes. Do you think it will harm future generations? Pretty much identical numbers, yes. Do you think it will harm people in developing countries? A little bit lighter, a few blue counties, but mostly orange, yes. Do you think it will harm you? Dark blue across most of the country, with the exception of a few areas where there are a lot of Hispanic Catholics and Native Americans, 2 people groups who are very concerned about climate change. What just happened here? Psychological distance. We agree that it's happening, that it will affect people in the future, far away in the future, but not now. It will affect people who live over there, not here. It will affect other species, plants and animals, but not us. We don't think it matters to us. One of the reasons for that is because one of the most common symbols for global warming or climate change is an animal that very few people have ever seen in real life in the wild. But the reality is, after the polar bear, we're next. We are the ones on that metaphorical iceberg. Why? Because climate change is loading the weather dice against us. Wherever we live, it's as if we have a pair of dice. And so we always have a chance of rolling a double 6 or a double 5, a record-breaking heat wave or a wildfire or a flood. So where does climate change come in? What's happening is it is sneaking in decade after decade as the planet warms and taking one of those numbers on our dice and turning it into a 6, taking another number and turning it into a 6, and then taking one of those numbers and turning it into a 7. So all of a sudden we're rolling double 6 after double 6 and even a double 7. And we say, where did this come from? Climate change is loading the weather dice against us, and it is affecting us everywhere that we live. So how do we address psychological distance? By bringing these changes home. Let me give you some examples of how not to and how to, starting with sea level rise. So sea level is rising, but when we look at these sort of colored lines for global mean sea level of 2 feet or 4 feet or 6 feet or even 8 feet, people think, what does that mean? Instead, when we talk about what's happening right where we live, how the price of coastal homes is dropping because flood risk is increasing, how they're raising the levels of the streets by 2 feet just so they won't get flooded, how sunny day flooding is on the rise and you can actually see cars driving through seawater on the roads. If you live in a coastal area, these examples bring it home. Let's talk about something even more esoteric, like ocean warming. People might think, well, how does this matter and how does this connect to my life? Well, as the oceans warm, it's creating marine heat waves that are bleaching coral reefs, which are the nurseries of the ocean. Toxic algae is on the rise as oceans warm. And you know what else? Warmer oceans power stronger hurricanes. Hurricanes are getting bigger and stronger. They have a lot more rainfall associated with them now than they used to. And they're getting a lot more dangerous and a lot more damaging. We could talk about how global temperature is changing, but when we talk about the crazy heat waves that we've experienced last summer with over 100 degrees Fahrenheit in Siberia, this summer with one small town in Canada breaking the record for the highest temperature ever set north of 45 degrees, and then the very next day the town burned down in a wildfire that swept through the town. We see things happening. We see extreme heat records being broken wherever we live, and this directly relates to how climate change is affecting us where we live. Wherever you live, the National Climate Assessment explains very clearly, and we actually have a global weirding episode for each region of the National Climate Assessment, how climate change is affecting you in the places where you live. It can be local. And not just local, not just here and now, but it's also important to make climate change relevant to what they care about already. So let's talk about local first, then relevant. How do you make it local? Well, for example, what about analyzing local data of temperature and rainfall and things like that to see what's happening? What about looking for local experts who might be able to speak to your group about things that they've seen changing in the place where you live? Local gardeners club, somebody who works for the city who's concerned about extreme heat or flooding. Like I said earlier, I work for the Nature Conservancy, and they've got conservation areas all over the country, as you can see from this map. Many of them are open to the public, some are not, but you still might be able to get somebody from them to come and talk to your class about what's been happening and how things have been changing and how it's affecting the birds and the butterflies and the plant species and the water. All of the things that are native to where we live are changing. There's also a lot of amazing citizen science projects that you might be able to get your students involved in. But not only local, make it personal too. What do your students care about? What are they passionate about? Are they into sports? Are they into their pets? You can look at how many danger days there are when you can't run around outside or play football or tennis or something like that because it's too hot, or when you can't leave your pet out in the backyard. Find out where their family goes for vacation is in a beach area that's experiencing sea level rise. Look at the type of food that they eat. Look at the things that they enjoy doing, the places that they've been before. Have them do a little bit of research into how climate change is affecting a place that they love or a thing that they love or a sport that they love. There's something for everyone, and everyone can care about it for a different reason. It doesn't have to be the same reason. In fact, everybody can have a completely different reason why they care. But the more personal and the more deeply connected that reason is to their identity, to their passions, to their heart, the greater the decrease, the faster the decrease in psychological distance. Because we no longer see it as an issue that is not only far away in space and time, but we don't see it as an issue that's far away in relevance either. We see it as something that matters directly to me. And there's an added bonus. This is Chris Chu. He's another one of my colleagues at Texas Tech University, and he studies psychological distance. You know what he found? He found that when we talk about climate impacts in a way that is relevant to us and that is here and that is now, as opposed to being far away or in the future or to things that we don't care about, not only does that decrease psychological distance, it decreases the political polarization as well. It's a twofer, as we say. So there's all kinds of good things that can happen by tackling psychological distance. But now I want to move on to the last item, which is frankly the most difficult. It's the biggest one, and that is our emotional response when we do get it. when we've had the facts clearly communicated to us in ways that address our misconceptions and our mental models and engage and spark our curiosity, when our psychological distance has decreased, when we realize that climate is changing here and now, the place where I live, in ways that matter to me, then that's when it hits us. This thing is real and it matters, and it's going to affect me and my family and people and places who I love. For a lot of adults, our response to this looks like one of two ends of the spectrum. Either extreme solution aversion, because we recognize that to fix this problem, we have to change the entire way that we live, the foundation of our society. And solution aversion is actually the cause of most of the climate denial that we hear about. It comes from fear. But at the other end of the spectrum, we also have fear. Fear of just being completely overwhelmed, panicked, anxious. There's this huge global issue, and I'm not a president or a prime minister or a CEO or a very important person, so what am I supposed to do about it? It's like NASA told you that an asteroid was going to hit the Earth and there's nothing you can do. For a lot of kids, this fear is often an immediate response because they get it. They understand this thing is bad. It's really serious. And for kids, it's powered by an even greater lack of efficacy. Efficacy is the idea that if we do something, can we make a difference? We don't think we can fix it. And so the toll on our mental health can be extreme. I see this myself. A colleague of mine just shared how her son, who's in elementary school, sort of started to put the pieces together on climate change, and he panicked. He was so afraid she had to take him to the doctor. I have another colleague who has to be very careful what she said in her class because she had one student, an undergraduate student, who would hyperventilate every time she mentioned the words climate change. Our emotional response is very real. And I want to be clear, I am not a psychologist. I'm not any kind of psychologist. But what I have done, what I have to do, what all of us have to do with this issue, I think, is we have to turn to the experts, to the ones who are psychologists. And so, for example, Renee Lertzman and Britt Ray have done excellent talks talking about the mental health aspect and the emotional response that we have to climate change. And as Renee says, the very first thing that we need to do is actually acknowledge our emotions, which for a scientist is always a bit of a difficult thing to do. But what I did was I kind of took that to heart and I thought, okay, well, how can I help my students acknowledge their emotions? And so what I started to do a couple of years ago is I started to add journaling to my science classes. And I didn't know how that would go. And at first I didn't even know how to respond to the journal entries. I had to ask one of my colleagues who's a technical writing instructor. I said, what do I do when they've given me their journal entries? Because they were amazing, don't get me wrong, but I didn't even know how I was supposed to respond. And he's like, well, just imagine they wrote you a letter. What would you say? So in journaling, I often ask questions, very open-ended questions. And I say, you can talk about whatever you want. If there's something else you want to talk about that. But if you're kind of, don't know where to start, what do you think about this? Or, set a watch for 5 minutes, set a timer for 5 minutes and write down all the things you're most worried about. And then reflect on how did that make you feel once you got it out? Or talk about, well, what did you used to think about that? Or what do you love most that you're most concerned about? So giving people a chance to express their emotions can really be incredibly powerful, just to understand, to acknowledge what we're feeling. If you'd like to know more, Renee has a project Inside Out with resources there, as well as the 2 TED Talks I recommended earlier. And there's also fantastic books like How to Talk to Kids About Climate Change. But we don't have to stop there with acknowledging how they feel. We can also help. How? Because fear is a very natural reaction when we find out what's happening to our planet and how it affects every aspect of our lives. But fear is fueled by helplessness, by the sense that there's nothing we can do about it. The opposite of helplessness is efficacy. The idea that if I do something, I can make a difference. If we do something together, we can make a difference. And efficacy matters because if we feel efficacy, we will act. And when we act, that's what gives us hope, the sense that there could be a different future. There's a possibility of a different future. But in the United States, over 50% of people feel helpless when they think about climate change, according to polling data, and over 50% of people have no idea where to start when it comes to climate action. So how do we build efficacy. We don't build it through a sense of false hope. You know, the classic book Pollyanna, just look on the bright side of life and assume everything will be okay. If we do that, we'll just be slightly happier until the axe falls, so to speak. And then imitating the proverbial, not the actual, of course, just the proverbial ostrich, is not going to engender a sense of efficacy either. Efficacy begins by understanding that it is possible to make a difference. And so just this year earlier on World Environment Day, I was actually asked, where do you find hope? And here's what I said. I said, I find hope in recognizing that I am not alone. You know, by myself, I can't change the world as one person, but I can connect with other people, and frankly, together, that's the only way that the world ever has changed, right? I am not alone. The giant boulder that is climate action is not sitting at the bottom of a very steep hill with only a few hands on it. In reality, that boulder is already at the top of the hill. It's already rolling down the hill in the right direction. There are millions of hands on it alongside mine. With more hands, we can make it go faster. And the more of us there are pushing it, the greater the possibility of a better future for us all. That's what gives me hope. So, what type of information can we share with people that engenders efficacy? We can talk about all of the hands that are on the boulder. Like what? Like the fact that there are amazing innovators creating technology that will suck carbon out of the atmosphere and turn it into fuel, or get energy from the tides. We can talk about how there's countries, entire countries, that are divesting from fossil fuels or becoming carbon negative by planting trees that suck up carbon from the atmosphere. We can talk about how there's large corporations like Apple or Microsoft or Walmart that are doing everything they can to power their activities from clean energy and to advance clean technology. We can talk about how there's the coal mining museum in Kentucky that puts solar panels on the roof, or United Airlines has been flying biofuel flights out of the LA airport since 2016. I love talking about what's happening in different parts of the world. How 90% of new energy installed around the world last year during COVID was clean energy. And how that clean energy is revolutionizing the lives of some people in some of the poorest places in the world, where they do not have access to coal or gas or oil like we do, but they do have a lot of sun and they do have a lot of wind. And last but not least, I love talking about what kids are doing. In fact, our most popular Global Weirding episode is the one about what kids are doing about climate change. And frankly, kids are putting us adults to shame. Whether it's schools, did you know that there's almost 6,000 schools across the US that use solar power? Whether it's projects that are doing things like turning cooking oil into biofuel, or altering people's behavior so you don't throw out as much food and you open the windows instead of turning on the air conditioning, painting the roof white to save energy, planting trees. Kids are inventing technology, like winning the Intel Science Fair for inventing an algae biofuel lab, or suing the federal government in Germany and Canada and the United States for the right to a better future. And of course, the Fridays for Future and the climate strikes, who is at the forefront of those? Young voices are. They are the ones who are telling us that the world needs to change. And what gets us moving? The idea that there might be the possibility of a better future. Real hope that is not based on some false sort of sense that it's all going to be okay. Real hope that begins by recognizing and understanding what's at stake, that accepts that success is not inevitable or even entirely probable, but that provides a vision of a better future and concrete steps that we can take to get there. As Greta Thunberg said, when we start to act, hope is everywhere. So instead of looking for hope, look for action. Then and only then, the hope will come. So my last tip is this. Make room for students to express and acknowledge how they feel. And do whatever you can to foster a sense of realistic hope and efficacy. Because you know what? They truly can make a difference. When it comes to climate education, we have a long way to go still. The National Center for Science Education graded each state according to its climate change curriculum last year. And as you can see, A's and B's are green, C's, D's, and F's are pink to dark purple. We have a long way to go, especially in the state where I live and maybe some of the states where you live too. But what's the first thing we can do to inspire our kids? We can talk about this issue. We can talk about how we know it's real, why it matters to us, and what are all the incredible things that people are doing to fix it. Because it turns out that when it comes to climate change, talking about it absolutely makes a difference. It kicks off a positive feedback cycle where the more we know about it, the more we care, the more we care, the more we talk about it, the more we talk about it, the more we know about it. And the best person to have those conversations is not me, the scientist. It's each one of us. It's friends and family and people we know and people we trust. And you know what? Kids are better at it than anyone. I love this amazing study by Danielle Lawson where she studied kids in a conservative part of the Carolinas for 2 years. And she looked at 2 groups of middle school kids, one group that was taught about climate change and one group that wasn't. And she surveyed the parents' opinions about climate change and how they changed over time. She found that parents of the children who were taught about climate change expressed higher levels of concern after that time than the parents of the kids who weren't. And get this, effects were strongest among male parents and conservative parents who had displayed the lowest levels of climate concern before the intervention. Daughters appeared to be especially effective at influencing their hard-nosed dads. So as teachers, you have an incredible and unique opportunity to help kids understand the greatest problem confronting us as humans today and what they can do about it to help. There's a lot of tools, a lot of resources, a lot of experiences out there that you can use. Of course, our Global Weirding episodes are here to help. And so now it's time to talk about what you know and what you think. As you break into discussion groups to share, and I really wish I could be a fly on the wall because I love getting new ideas and hearing new stories, share what has worked really well that you would recommend to others. What has failed miserably, recognizing that we often learn from our mistakes? What's something that you heard today that you think that you could implement? Of course, there's no magic formula that will convince everybody immediately that, yes, this is really important and we have to do everything we can. There's no perfect way of putting things. There's no special phrase or word that if you just use it, that'll get everybody on board and help everybody to understand it. Everybody's different. Everybody interacts with this information in a different way. But by listening, by caring, and by helping people make that personal connection themselves, I am absolutely convinced that every single one of us truly can make a difference. Thank you.